Hello. So I hope you have remember what we have learned in the last class. What all things we have learned? We have learned about optimization algorithms, how an error is calculating, the difference between the predicted output and the ground truth model. Ground truth is in the sense we have already the class we have with us, right? So we are comparing the actual output and the predicted output. How the error comes, then what is the optimization? We need to reduce the error, and then we have studied about the gradient. What is the gradient? It is the steepest increase. So optimization means we need to go back towards the go in the opposite direction of the gradient. So all those things we have seen. So in this class we are going to see about the bias variance trade-off. This is very important. Bias variance trade-off is very important. So in this video you are going to see what is bias, what is variance, and what is the trade-off between. Trade-off means there should be some kind of uh, low and high in that bias variance trade-off. We need to keep in that mind ki bias should not go beyond some value, should not go, and variance is also should not go low beyond some value. Like that we have to need a trade-off between bias and variance. Then we are going to see how a generalized model will looks like. Okay, so next we are going to talk about this figure. From this figure, what did you understand? In first figure, we are having, that jeans is little fit, right? So अच्छा नहीं लग रहा है ना उसको. Similarly, in the next fit में क्या है? Is that good? Whether we are would like to dress in that way? No, because it should be correct fit. Whether we are having larger size or small size or medium size, whatever, we have to keep our dress according to our size. So these three things are not good enough, right? So the first one is overfit, second one is underfit, and the third one is the correct fit. Okay, similarly our model is also having the same thing. It's an overfit. It should not be an overfit model, it should not be an underfit model, it should be a generalized model. Okay, our model which was trained by us should be a generalized model, that is it should be correct fit. How it happens? See, for example, we are taking the home price and square feet area prediction. Okay, home price and square feet area prediction. So in that thing we have many data points here. So for this point we are having, for this square feet area we are having the home price like here. So for this, here there is a square feet area, and for his there should be some home price, and for this square feet area will be like this and home price will be considered like this. So for each square feet area we should be having a home price. And how will we calculate a new data if it comes? If a new data comes, how will we declare? If a new data comes, first we will check in between this. These are the training example. So we will check whether that new data square feet area is comes under in which line it is, and then we will check whether home price is between that or not. Then we will predict that. Okay, so it should be more or less similar to the tested training data set. Then only we will understand that our test data, our model has performed well on the test data. It is very important. So if this is my model, this green line is my model, generalized is my model that worked on the trained data set. Okay, these blue dots, let it be the trained data set, and these orange dots are my red data test data set. So if my model is working on this, these are my training data set, then it worked well on trained data set. Kyun? Because all those points it has captured. My model has gone through each and every point of training data set. But what happened? So actually train error is zero. Train data set error is zero because our model has well predicted through all those things. But what about the test data set? Test data set is having 100% error. Kyun? Because if the data point is here and here the data point is here, but the home price is different for both of that, because how will we calculate? Iska square feet will comes under here and home price will be here, and this one square feet under here, and this one square feet under here. So we need to check in between this how much square feet and home price is there. So there should not be much variation should not be there. If that variation is there, then there is an error. So in this case, if we are seeing all the points, if we are going through all the points of the trained data set error, it's an overfit model. That means it cannot generalize. So here test data set error will become 100. So what happens for this figure? If my generalized model is changed, my model is changed a little bit by this, like this. Okay, it has taken some more points, some other points from here to here. Okay, from here to here, if I'm coming, some data points have changed. So what happens? My trained data set error is 0 itself, because this is the trained data set, but test data set error is reduced but not 0. Okay, it is become 27 in this way. So what is the conclusion that we understood from these two figures? These two figures, there is in the initial way the test error is 100, and in the second method the test error is 27. That is very high variance in between 100 and 27, right? So what is high variance? This is the case of high variance. Here test error varies greatly. Test error varies greatly according to what? According to how we chose the test train error. I mean, each time when shuffling and we are taking the training data set, our test error is becoming having very much high variation. This should not be there. So this happens in an overfit model. If we are coming to this picture, what happens here? A straight line is there, right? A straight line, first of all, a straight line is not a good method for a model. Okay, we should not have like this. So what happens in this way? If like this, then trained data set error is 43, because we haven't meet all these points, right? So trained data set error is 43, test data set error is 47. Error calculation is the same between the model predicted value and the actual value. Okay, so the actual value will be in the data set itself. So if we are taking similar two examples with a straight line, what we have got? Train error is 43 and 41. Similarly, we have a test error as 47 and 37. So what happens? Even though there is low variance in test error, 47 and 37, there is very less variation. But what is the point? There will be a problem of bias. Bias is what? Bias is related to the generalizability of the model. The model which we trained, the model which we trained on the data set should be having a general pattern to see to capture the unseen data also. That is test data also. But in the above case, the model, our trained model is failed to capture the test data, that is unseen data. There comes the bias. So bias is a measurement of how accurately our model can capture a pattern. For a data set, there will be some features. According to that features, the model will capture the pattern of the data set, how it moves. So that fails to capture the pattern in the training data set, right? Now, if we are taking this case, what happens? This exponential method, this exponential line shows a very good generalizability of the model. So what happens? Here there is some data set error 10 and test data set error as 12. And if we are taking another example of the same exponential, we are drawing the exponential line through another set of trained data set. Again, the train error is 11, test error is 15. That means there is low variance test error, first test error and second test error between 12 to 15. Low variance, low bias also. Bias means train accuracy. In the initial method, train accuracy was what? Our train accuracy was 0. Train accuracy is 100, train error is 0. But here what happens? The train error, sorry, I have said here that train accuracy. No, train error is 10. That is very low. Even though there is some sort of error, but it can be manageable. So train error is 10. Okay, and here 11. This is low bias. So we need to choose in that way ki low bias and low variance. Okay, this is regarding this thing, the same bias variance trade-off on a diagram of circle diagram that we will going to learn in the next class. That in continuation of this video we will learn. Okay, thank you.